So these are the practice box problems you'll find in your note packet. If you'd like to, you can go ahead and use your solubility curves from your note packets or study packets and hit pause and try to solve these yourself. That's always a good practice. But before you try to solve them yourselves, I want to give you two heads up. First of all, I want to tell you what RT stands for. Number one, RT stands for room temperature. It's just a little known fact that room temperature in Celsius is 22 degrees, so I think that information will help you. And another little heads up, potassium chloride, which is in number 3, this compound KCl cannot be found on all solubility curves, but it will be found on the solubility curve on page 9 of your notes or in the study packet. I think it's there too. So just want to give you those two heads up if you're going to go ahead and hit pause and try to solve them yourselves first. But if you're ready to move on, then go ahead and keep watching so you can see how to solve these 3 problems. Here's the first problem. We have a solution. It has 120 grams of sodium nitrate. It's dissolved in 100 milliliters of water at room temperature. We want to know if this solution is saturated, unsaturated, and supersaturated. So just as a little review, saturated means that it has its maximum amount of solute dissolved, meaning you can't dissolve more solute, you can't dissolve less. Unsaturated means it's unfull. That means our solution can actually absorb more solute. And supersaturated means that our solution can actually take in more solute. Is taking in more solute than it theoretically should. It's like to create a supersaturated solution, you actually have to heat up a solution, slowly cool it down, and trap the solute inside of the solution. So just want to remind you of what those terms mean. Now, to solve this problem using the graph, basically all we're doing is we're finding the intersecting point between 120 grams of sodium nitrate. So 120 grams of solute is right there. And we're finding the other intersecting point to represent the x-axis, 22 degrees Celsius. Now, when we find those intersecting points, we want to see if it's on the sodium nitrate curve, under the sodium nitrate curve, or over the sodium nitrate curve. So we definitely need to know what sodium nitrate is. And if you are starting to scan the different compounds here on this graph, you want to try to figure out which one it is, and it's the one that starts with sodium. And if you need to verify that this is nitrate, flip your periodic table over, and nitrate's on the back of the periodic table listed as a polyatomic ion. So this is our curve of interest. Now, when we find the intersecting point between 120 grams and 22 degrees Celsius, it intersects here, and this intersecting point falls above the sodium nitrate curve, which means we're talking about a supersaturated solution. For this problem, it says how much potassium nitrate is dissolved in 100 grams of water at 50 degrees Celsius to make a saturated solution. The first thing we want to do is we want to know what potassium nitrate is. As we scan the different curves here, we're looking for potassium, and we see potassium here, a potassium here. And when we flip the periodic table over, we will see under the polyatomic ion section, this is chlorate and this is nitrate. So we're going to highlight this curve for this particular problem. And then I want to make another little note that saturated means we're talking about a point on the line, a point that actually hits the line. And we can actually see that in this part as well, how much potassium nitrate is dissolved in. All right, so we're finding the intersecting point between 50 degrees Celsius and the potassium nitrate curve. So locate 50 degrees Celsius. We're going to go all the way up until we hit the curve, and it hits at 80 grams, and that is how much potassium nitrate, that is how much solute you can dissolve in 100 grams of water. No red flags here because 100 grams of water means that we do not have to set up a proportion. So this is all you have to do for that problem. The next problem is actually extension of this one. If I have 65 grams of potassium nitrate, it's dissolved in 100 grams of water at 50 degrees Celsius. It's asking how much more we can add. So according to the previous problem, we can dissolve 80 grams when the water is 50 degrees Celsius. But this problem tells us we only have 65 grams at this point. So how much more can we add? We can go about solving this in two ways. One, we can go ahead and say, well, 80 is the max. We already have 65. That's 15 grams more. That's the answer. Or you can just take your point on the graph and just count up until you hit the line, and that's 5 grams, another 10 grams, so a total of 15 grams to get to the line. Same, two different ways to get to the same answer. Finally, in this question, it's asking what volume of water do I need to make a saturated solution containing 1,000 grams of potassium chloride at 50 degrees Celsius. Now, this is the solubility curve that can be found on the page 9 of your note packet, and we're looking for potassium chloride, but I want you to watch out because there's a KCl and there's a KClO3. These two look really similar, and people interchange these all the time, but we need to make sure we know which one's the right one. If you flip over your periodic table to look at your polyatomic ion list, ClO3 is chlorate. You might remember from the naming unit that Cl minus is chloride, and we need to make sure that we are focused on KCl, potassium chloride. Now, the problem is asking what volume of water. So a red flag goes up and it tells us that we're actually going to have to do a proportion in this problem. And with the proportion in this problem, water is actually going to be our X. So here in the problem, we're trying to make a saturated solution containing 1,000 grams of potassium chloride. So this is the amount of solute in X amount of water, according to the problem. Now, what we can get from the graph is that at 50 degrees Celsius, which is here because Celsius is on the x-axis, at 50 degrees Celsius, potassium chloride hits at the 40-degree mark. And it's slightly off. Sorry about that. It hits at the 40-degree mark if you look a little bit closely. I think my graph just shifted a little bit. And that tells us that 40 grams of potassium chloride can dissolve in 100 grams of water. So 40 grams can dissolve in 100 grams of water, according to our graph. How 1,000 grams of solute can dissolve in how much water? It's just completely proportional. The same ratio of solute goes into the solvent, so we set up a proportion, and we can do 1,000 times 100 divided by 40 to get 2,500.